What's up, guys? It's Kayla
and Jim.
Welcome back to another Meteorology Monday. What are we talking about today?
Today we are going to do a case study. Hurricane Helene,
Yes.
2024, Category 4 hurricane. A lot of people know about this one. It was recent, obviously, so a lot of things going on with this hurricane.
Yes.
We're going to talk about the meteorological setup. We're going to talk about its effects, both as it made impact to the shore as well as inland. We'll talk about some of the tornado outbreaks that occurred with it. But before we get started,
If you find that you are enjoying this case study and case studies like it, be sure to leave a like and subscribe down below so you never miss the next Meteorology Monday. Now let's get into the meteorological setup for this event.
on September 20th, 2024, a large low-level cyclonic circulation formed over the Central American region. Heavy rain and gusty winds were felt well away from the center. By 12Z on September 23rd, the large circulation drifted northward and was over Central America and the northwest Caribbean Sea. Deep convection began to occur about 130 nautical miles south of Grand Cayman due to a mid-level circulation moving overhead. A potential tropical cyclone advisory was issued by the National Hurricane Center since it was expected to become a tropical cyclone and spread tropical storm conditions to land areas within the next couple of days. Over the next 24 hours, more thunderstorms developed within the core of the developing cyclone as it moved slowly northwestward over the northwestern Caribbean Sea. Around 12Z on September 24th, the low-level center continued to intensify about 175 nautical miles south of the western tip of Cuba. Aircraft and satellite data were able to estimate maximum sustained winds around 40 knots or 46 miles per hour. Helene was now a tropical storm.
As the day wore on, low wind shear, high moisture, and very warm sea surface temperatures allowed thunderstorms within Helene to grow and consolidate near the center, with spiral banding increasing outward in a counterclockwise fashion. By 6Z on September 25th, Helene was located about 50 nautical miles east of Cozumel, Mexico, with maximum sustained winds of 55 knots or 63 miles per hour. Over the next 6 hours, Helene would continue to intensify and become a Category 1 hurricane just east of Cancun. At the same time, a stationary front stretched from the central Gulf Coast northward toward the Tennessee Valley and southern Appalachians. Along and east of the front, strong, low-level southeasterly winds were driving moisture into the south-facing slopes, which forced air upward, creating heavy rain and flooding well in advance of Helene. These conditions set up the Predecessor Rain Event, where heavy rain had fallen not long before the next major rain event. This set the stage for the historical rainfall and flooding felt over the next few days across Georgia, South Carolina, North Carolina, Tennessee, and Virginia.
Tropical storm conditions spread over portions of the eastern Yucatan Peninsula. At 1745Z, a weather station in Almajeras recorded a minimum central pressure of 989 millibars as the center of Helene moved within 45 nautical miles north-northeast of the station. An hour later, that same station measured winds of 46 knots or 53 miles per hour with a gust to 60 knots or 69 miles per hour. Helene would continue to move northward into the Gulf of Mexico later that day, as it was positioned on the western side of a subtropical ridge centered over the western Atlantic. Satellite and aircraft data indicated that Helene developed a secondary wind maximum further away from the center late on the 25th or early on the 26th. Meteorologists noted that this could have caused the rapid intensification to slow down significantly. However, during this same time, the wind field began to expand rapidly. Tropical storm force winds extended outward up to 360 nautical miles from the center in the northeastern quadrant. By the early afternoon of the 26th, Helene rapidly intensified over the very warm Gulf waters and began to accelerate north-northeastward as it was situated between a ridge to the east and a cutoff low over the Tennessee Valley. Maximum sustained winds increased to 105 knots, or 120 miles per hour, making it a major hurricane as it passed about 150 nautical miles west-southwest of Tampa, Florida. This would mark the beginning of the prolonged heavy rain event that would be felt across the Florida Panhandle, northward into the southern Appalachians over the next few days.
By 2145Z, minor flooding was occurring in the French Broad River in Asheville, North Carolina, as the level reached 10 feet. About an hour later, NOAA buoy 42036 in the northeastern Gulf of Mexico, located within the western eye wall, measured a sustained wind of 69 knots or 79 miles per hour, gusting to 93 knots or 107 miles per hour. Dropzone data measured Helene's central pressure around 941 millibars. Over the next 6 hours, Helene would reach her peak intensity of 120 knots or 138 miles per hour, around 80 nautical miles south-southwest of the coast of the Florida Big Bend region. Continuing on a north-northeastward track, Helene would make landfall as a Category 4 hurricane about 10 nautical miles southwest of Perry, Florida, around 310Z on September 27th. The minimum central pressure at this time was 939 millibars. This makes Helene the strongest landfalling hurricane in the Florida Big Bend region since reliable records began around 1900. A couple minutes later, the Texas Tech StickNet site, located halfway between the landfall point and Perry, Florida, measured a minimum pressure of 942.8 millibars. Many areas in Georgia and the eastern Florida Panhandle set their all-time record lowest minimum pressures as Helene moved through.
Hurricane-force winds were overspreading areas of northern Florida and southern Georgia along and east of the center's path. At 420Z, a weather stem site in Lowndes County, Georgia, measured winds of 53 knots and gusts of 83 knots. At 612Z, a weather flow station on Jekyll Island, Georgia, measured winds of 53 knots, gusting to 68 knots. At 615Z, a University of Georgia WeatherNet station in Coffee County measured a wind gust of 80 knots. At 703Z, a sustained wind of 49 knots with gusts to 87 knots was measured at Bacon County Airport in Elma, Georgia. At 739Z, the first weather-driven flash flood emergency was issued as the core of Helene approached the western Carolinas. At 754Z, Savannah Light, located along the Georgia coast, measured sustained winds of 54 knots, gusting to 68 knots. As the hurricane started to interact with the mid to upper level low over the Ohio Valley, it would take more of a northward track, continuing at the same forward speed. Hurricane-force wind gusts were felt far inland due to the fast forward movement of the storm and wide expanse of the strong wind field. Helene remained a hurricane even over southern Georgia. According to the National Hurricane Center's Tropical Cyclone Report on Hurricane Helene, it is important to note that many of the weather stations along Helene's path in Georgia and South Carolina stopped reporting before the peak conditions occurred. National Weather Service forecast offices conducted ground surveys of damage which suggested wind gusts likely exceed 70 knots in a large area from the Florida Panhandle through eastern Georgia and into central and western South Carolina. Tree and structural damage suggest wind gusts may have exceeded 90 knots in some of these areas.
Around 9Z on the 27th, Helene weakened to a tropical storm around 30 nautical miles east of Macon, Georgia. Maximum sustained winds were 60 knots or 69 miles per hour. Just a few hours later, the center of the storm moved northward to near the Georgia-South Carolina-North Carolina border. Widespread flooding, landslides, and strong wind gusts were occurring across the southern Appalachian mountain region. Hurricane-force wind gusts continued to be felt east of the center across the higher terrain areas of western North Carolina and as far east as the Georgia-South Carolina coastal plain. Around 12Z, Mount Mitchell observed sustained winds of 70 knots or 80 miles per hour with gusts to 92 knots. A wind gust of 88 knots was recorded near Banner Elk, North Carolina. Frying Pan Mountain in North Carolina observed sustained winds of 55 knots and gusts to 76. Many mountain peaks in western North Carolina had extensive tree falls and damage due to these wind gusts. Tropical storm force winds were felt across the Charlotte region and as far away as Southport, North Carolina, near the coast. At 1600 Z, the French Broad River in Asheville, North Carolina, reached major flood stage of 18 feet. As the day wore on, the storm took a more northwestward track and merged with the cutoff low to the west. Helene would become post-tropical in nature around 18 Z that day as it moved into southern Kentucky. Maximum sustained winds were around 40 knots, or 46 miles per hour. Over the next 24 hours, the post-tropical low would slowly dissipate as it made a cyclonic loop over north-central Tennessee.
Widespread landslides and historical flooding took place as up to 30 inches of rain fell over the mountainous parts of western North Carolina. 10 to 15 inches of rain fell over southwest Virginia, northwest South Carolina, and portions of Georgia and Florida, with 5 to 10 inches of rain falling over adjacent areas. Rainfall totals of 3 to 6 inches were observed across portions of the Tennessee and Ohio valleys. At 2200 Z, the French Broad River at Asheville, North Carolina, was at 24.8 feet, which exceeded the previous record of 23.1 feet set in 1916. Around the same time, the Shenandoah River at Biltmore, North Carolina, reached a peak stage of 27.33 feet, far surpassing its previous record of 20.7 feet, also set in 1916. In addition to the widespread wind damage and extreme flooding, 39 tornadoes were observed across the southeast associated with Helene's circulation, including 3 in Florida, 3 in Georgia, 21 in South Carolina, 9 in North Carolina, and 3 in Virginia. Many were rated EF0 and EF1. However, there was 1 EF2 in Virginia and 1 EF3 in North Carolina. An EF1 tornado in Wheeler County, Georgia, killed 2 people, taking shelter inside a mobile home during the evening of September 26th. The tornado was only on the ground for 0.6 miles. A long-tracked EF1 tornado occurred just after midnight local time through eastern Orangeburg and western Calhoun counties in South Carolina. The tornado was on the ground for 29 miles, traveling at an average forward speed of 56 miles per hour, and had a width of 800 yards. A very wide EF1 tornado, spawned within the circulation of Helene, occurred in Cordova, South Carolina on September 26, having a width of 1,100 yards. This size is the largest known tornado in the U.S. Tropical Cyclone Tornado Database, dating back to 1995. Another wide EF1 tornado ripped through Sumter County, South Carolina, around 9:32 Z. The width was about 1,000 yards. In North Carolina, one EF3 tornado occurred around 1730 Z on September 27th in Nash County. In Virginia, an EF2 tornado occurred in Pittsylvania County.
In summary, 250 people lost their lives, and 117 more were injured. Of the 250 people who lost their lives, 14 fatalities were caused by storm surge, all of which were in Florida. 65 fatalities were related to the hurricane's winds, of which 61 were from falling trees during the storm. 2 deaths were caused by a tornado in Georgia. There were many indirect fatalities from medical issues, heart attacks, car accidents, and incidents during post-storm cleanup. There were 2,700 water rescues. About half occurred due to storm surge along the western coast of Florida. More than 1,000 were due to freshwater flooding in western North Carolina. Helene was the deadliest hurricane in the contiguous U.S. since Katrina in 2005. In comparing Helene's wind field to other hurricanes at similar latitudes over the southeastern Gulf of Mexico over the past 20 years, NOAA observed that it was larger than about 90% of systems of similar strength. 20 to 30 inches of rain was recorded in North Carolina. Busick, North Carolina recorded 30.78 inches of rain. Sunfish Mountain in Greenville County, South Carolina, measured 21.66 inches of rain. A large area stretching from northwestern South Carolina to western North Carolina and southwestern Virginia received 3-day rainfall totals that had less than a 1 to 1,000 chance of occurring in any given year. Over 2,000 landslides were documented by the USGS, with the majority located over western North Carolina. Preliminary estimates found that at least 63 streams and river gauges across northwestern South Carolina, southwestern North Carolina, northeastern Tennessee, and southwestern Virginia exceeded their record flood levels during Helene. There were 39 tornadoes directly associated with Helene. The total amount of damages from Helene was $78.7 billion US. This makes Helene the 7th costliest US hurricane adjusted to 2024 values, behind Katrina, Harvey, Ian, Maria, Sandy, and Ida. An estimated 7.4 million customers, about 16.2 million people, lost power in the United States due to Helene between September 26th and September 28th. The maximum outage count at any given moment in time was about 4.79 million customers. Florida experienced the largest loss of power, with 1.69 million customers losing power. South Carolina, Georgia, and North Carolina experienced an estimated 1.59 million, 1.28 million, and 1.18 million outages, respectively.
So that is very, very interesting.
Yeah.
Just summarizing this massive storm. What was the thing that stuck out to me most was the heavy rainfall and how quick the streams and rivers flooded, well above the 1916 flood stages.
Yeah, and if you're unfamiliar with this area of the United States and what happened in 1916 in the western North Carolina area, that flood was labeled a 1,000-year flood, which of course, as one of the statistics pointed out for Helene, this also caused another 1,000-year flood, which having 2,000-year floods within 100 years of each other is insane, and that has a lot to do in this situation with the Predecessor Rain Event that took place just before Helene made its way through the southeast United States.
So when you add, was it like a 3-day event of heavy rainfall, saturating everything, rising those river levels, and then you've got a hurricane, large hurricane, big wind field, moving into an area where it has all the orographic effects of wringing out all that moisture over that same area. It just makes, these numbers huge, more than we've ever seen, obviously.
Yeah.
Just thinking, 30 inches of rain. I mean, imagine, a heavy, heavy thunderstorm just dumping buckets of rain.
2.5 feet of rain.
Yeah, a heavy thunderstorm probably gives you 1 inch, 2 inches, lasts 45 minutes maybe on average. Just imagine like 30 times that. You look out your backyard and, trees are gone that used to be there for hundreds of years. Hillsides change. Towns change.
Tops of mountains, the rivers, the lakes, literally everything. Here we are sitting almost a year later, and speaking from the North Carolina perspective of things, the sheer amount of devastation in western North Carolina and the way that there's still debris being washed down the rivers almost a year later, and parts of the Blue Ridge Parkway going up to mountaintops is still not accessible due to the amount of trees that fell down due to the rain and the wind. Absolutely insane weather event.
Fortunately, not every square inch of North Carolina and South Carolina in those areas were impacted to that level of devastation. So some areas were able to recover quicker than others, but yes, even a year later, there's still effects from this hurricane.
And I know over the past few months, a lot of you guys have been asking questions about the impacts that we felt directly from Helene in the Charlotte area. We did experience some flooding, mostly flash flooding, that went away pretty quickly. A bunch of our rivers did rise. We have a video on that posted if you want to check that out. But our area got nowhere near the devastation that western North Carolina, eastern Tennessee, and parts of South Carolina and Georgia experienced. Another big fact about this hurricane is the amount of tornadoes that it produced. Now, while it's not rare for a tropical cyclone to produce tornadoes, there was the one that was the widest associated with a tropical system like this in recorded history since 1995, I believe. But there was another hurricane that happened just after Helene that had an even bigger tornado outbreak associated with it.
That's right.
What hurricane was that?
That would be, come on, help me out. You guessed it, Hurricane Milton.
Hurricane Milton, because if you can believe it, back-to-back hurricanes, because the Atlantic really hated the months of end of September and beginning of October 2024, apparently. But yeah, Milton is another very interesting case study we have planned coming up for you guys, so be on the lookout for that one coming out within the next couple months. So there you have it, September 2024's Hurricane Helene case study. Again, if you like what you saw, be sure to leave a like and subscribe down below so you never miss the next Meteorology Monday, so you don't miss the Milton case study coming up here soon. The Atlantic Ocean looks like it has decided it remembered its hurricane season, so there might be other hurricane content coming soon. You don't want to miss it. Follow us over on Facebook and Instagram. If you missed out on our storm chasing series where we went out to Tornado Alley for a couple weeks earlier this year, I will leave that link in the description box. There are about 5 episodes in this season of Storm Chasers Meteorological Weather Edition. Highly recommend you check that out. It was super fun while we were out there. We saw 5.5 tornadoes, and you'll see what the half is when you watch the series, so definitely check that out if you haven't already. And if anything that we've talked about today interests you in the slightest, might I present to you our School of Weather, where you get to learn the basics of meteorology, get into the nitty-gritty of severe weather, such as hurricanes, without having to go to college, spend all the money on the degree. You get to work on it at home, at your own pace. It comes with PDF guides that really help you understand the content and walk you through it. And if you have any questions at all while you're doing it, we of course are available via email anytime. If you want to help support the channel, our Patreon is linked down below. Until next time, I'm Kayla.
And I'm Jim.
Thanks for watching.
And we'll see you at the next Meteorology Monday.
You know what I have not had yet today?
Coffee.
A coffee. You know what I'm about to have?
A coffee.